Hi everyone, welcome back. We will continue our study on conjugate heat transfer. But previously, I have introduced how to construct the file structure for OpenFOAM from scratch. I recommend you going back and reviewing of all the previous settings if you haven't done so. But if you feel confident doing that, I think you have been ready to go to the intermediate level to prepare yourself for the industrial applications, especially by dealing with 3D geometry model. I think that is the biggest difference between the academic and the industrial users, because in the industry there are more complicated shape or geometry that to be delivered to the customers, and that's why the engineers need to analyze the performance of the real 3D geometry model. So let's get started. But before that, I want to address the previous studies. Previous studies tell us there are mainly multiple steps to define the files and prepare it for the solver of using OpenFOAM. And I just did very minor work on the post-processing here. But you can say half of the steps is mainly focused on the preparation of the meshes, which means the meshes are always our priority to do. And in the following series, you will be finding that there will be more work that will be integrated into these steps I highlighted here from step 2 and 5. We will try to manipulate and add more steps or more operations meshes by preparing it for the followings. And then from step 6 to 11, that is more standard operation, and you just need to change the boundary conditions, physical properties based on the new definition, and the steps are the same, but for the real or complex 3D geometry, the step 2 or 5 need more work to be performed to prepare the meshes good enough for you to work on. And that's our topic part 1. So how to construct complex geometry. There are different tools that you can use. Here I will introduce the snap hex mesh, which is a tool that is along with OpenFOAM, so you don't need to any mesh conversion from other or extra software tools. You can just use the OpenFOAM to do this. And what I mainly found is that the snap hex mesh is very powerful tool compared to the other solvers, because OpenFOAM really think it's a solver without any GUI or like guest user interfaces. But the snap hex mesh is really help you to prepare your models to be the real 3D geometry, right? So let's get started on the real problem or real problem description. So I define it as macro heat exchanger. So heat exchanger as well, very similar to our previous setting. So we have the hot air as a hot medium and cold water as the cold media. So the performance of our devices or equipment is to transfer the heat between the hot and cold. We always know the inlet conditions of the media because we use it as an input, and by simulation or the CFD, we want to get the real or the exact outlet conditions to check if it satisfies the heat transfer performance. And of course, it is not two-dimensional now, it is three-dimensional, as we have the depths for the air side, which has depth of 10, and the water side has depth of 5. You will see it is very, very tiny or very thin heat exchangers. You can imagine it can be used in the electronics cooling or have some very compact arrangement cooling requirement, or let's say warming requirement as well. And the geometry itself is also very tiny. We have a total dimension, so along this this direction is about 150 plus 60, so it's around 20 centimeters. And the height or the y direction, I think it is about 100 like 15 centimeters. So it's very compact heat exchanger, or called macro heat exchanger. And the shape itself is not regular, so maybe a bit regular on the hot air side, but not regular for the pipe or the cold side, because it has coiled shape and it has curve here. And this shape means the block mesh cannot deal it so easily for the complexity. There are some advanced users that can use the block mesh to deal with this, but you need a lot of imaginative work for it. To deal with this mesh or this geometry, the OpenFOAM provide a tool called SnapHex Mesh, which is a very useful tool, or the only tool you can use by using OpenFOAM to deal with any complex meshes. And of course, because we are dealing with the conjugate heat transfer, which means we still need the regions to be properly splitted, if you remember, and also we need more pre-processing work on this by adding SnapHex mesh and split regions, and maybe also a bit operation or manipulation of the boundaries.